Okay, folks, so we're here for our second lesson of the week, and it's going to be about slope. So, slope, we know, is a representation of how steep a line is on a graph. When we think of steep, we think of a mountain or a hill, how steep it is, okay? And we can find how steep a line is on a graph two ways. We can use the graph or we can use algebra. We're going to learn both ways. So looking at the slope here, we find slope by rise. Rise is how much it goes up or down. And run. Run always to the right. Run is always to the right. Okay, so we start at a solid point here, right at the intersection, right at the crosshair, and we travel from this point to another point that's right on the crosshair. And are we going up or down? Well, we go up. We go up 2 in the y direction. That's our rise, right? And then we go over, or we run 3. Okay? And slope is rise divided by run. Rise over run. 2 over 3 in this specific situation. Okay? Now, we can also use this equation over here if we have the coordinates as opposed to just the graph. Okay. Now, there's a couple of different types of slope. We can have a positive slope. With positive slope, we're reading from left to right, just like we read a sentence from left to right. We read a graph from left to right as well. Left to right, left to right, left to right. Okay, so when reading from left to right, if you are going up, that's a positive slope. If you're going from left to right, you start on the left and you go right, and you're going down, that's a negative slope. A horizontal line, when we think of horizontal, think of the horizon, right, where the sun comes up. Okay, that's my picture of a sun right there. A horizontal line, the slope is 0. Okay, and a vertical line, we think of a basketball player's vertical jump, right? Vertical, up and down. If it is straight up and down, then the slope is undefined, or there is no slope. Okay, cool. So looking at these, it says find the slope of each of these graphs. Now, again, just like we did the last time, we start on the point on the left. Always start left to right, just like in PEMDAS and reading a book, in mathematics, left to right, okay? So starting at the point on the left, should we go up or down? Well, looks like we're going down 1. We go down 1, okay? So that's our rise is 1. Now we go over 2, so that is our run. Our slope for this line is 1/2. Down 1 over 2. Oop, made a big mistake. Negative 1/2. Because you're going down 1, it's negative. Careless mistake, I apologize. Negative 1/2. Now, looking at this line right here, we could do the math if we wanted, where we start at the point on the left. This one doesn't really have a point on the left, so we just pick either point. And are we going up or down? We're going down. So that's down 2, so a negative 2. Forgot that negative on the first one. Please forgive me. Negative 2. And are you going over at all? No, it's just straight down. So it's over 0. And if you try to type this into the calculator, negative 2 divided by 0, it'll give you an error. The reason for that is you cannot divide by 0. Therefore, this slope is undefined. Any vertical slope is undefined. We noticed that this was a negative slope, which is why it was negative 1/2. This right here is undefined, so we can actually write out the word undefined. Now we notice this one is a positive slope. We start at the point on the left, and we go up 1, 2, 3, 4, 5. So we go up 5, and we go over 1, 2, 3. 3 boxes over. So our rise is positive 5, and our run is 3. 5/3. Unsurprisingly, this is positive. Positive slope, positive slope. Last one. This is a special situation, but we'll pretend it isn't. Now, we're going to start right on the point on the left, and do we go up or down? Neither. It's not rise or run, so it's just 0 divided by. And we go 1, 2, 3, 4, 5 over 0 divided by 5 is just 0. This is a zero slope, horizontal line. Okay. Now, again, we can find these algebraically as well as on a graph. We just practiced how to find them on a graph, right? On a graph, we go from the point on the left, we would go up 3 and over 4. So this slope would be 3/4. Now, let's see if we can verify that with algebra or with our equation here. So we already know that the slope is going to be 3/4. We can see that from a graph. But if we use the points, we can prove that that's true. Now, this coordinate right here is 3, 2. So I'm going to write that down, 3, 2. Comma in the middle and a couple of parentheses. This one right here, this point is 5, 6, 7. 7 is our x value. And our y value is going to be 6. Okay. 1, 2, 3, 4, 5, and 6. Okay. Wait. 1, 2, 3, 4, 5. No, totally just 5. Make a lot of mistakes today. So careless. Okay. So this is 5. Now, using the slope equation here, we can plug in our y2. So we'll put slope is equal to y2. Our y2, it says, is 2. Right here, y2, 2. Just means the y value of the second point. Okay? Minus y1. y1 here is 5. Minus 5. Over, or divided by, and then it tells us x2. x2 is 3. And minus x1 is 7. Notice that the 3 and the 2 are from the same point. The 5 and the 7 are from the same point. If you accidentally switch these around, you will get the wrong answer, so please be careful, or rather the wrong value for slope. 2 minus 5, negative 3, and 3 minus 7 is negative 4. Now, because there's a negative in the top and bottom, we can simplify this to just 3/4. And sure enough, that's the same as the one we found from the graph. So we can use the equation or the graph to find the slope. Okay? And that is all I have for you today, folks. Please email me if you have any questions, and keep working hard.